Okay, so we're going to go over the assignment titled Periodic Table Basics, and we're using this question sheet right here that was with the assignment when it was posted. And you should have your periodic table completed with all those blocks, and the completed periodic table is going to look something like this. Okay? Can you see that good on the screen? All right. So you see that it's color-coded, and what happened to your colors when you ended up arranging like it was supposed to?
They lined up.
They lined up in the same columns, okay? They lined up in the same columns, and some of you noticed that. Some of you are like, oh, they lined up. That was on purpose, okay? So we want to start with number 1, and we're going to go through and talk about this and talk about the relationships and the patterns that we see. Okay, so number 1 says, which elements had complete outer shells? What do you think complete outer shell means?
The ones with the 8 dots.
They're full, okay? So full is 8 valence electrons. Which ones had 8 valence electrons?
Argon had one.
Argon had one. Neon had one. But we have a third blank. So what is our third one with a full outer shell?
Wait, is it hydrogen?
It is helium. Why is it helium?
Oh, because it can only have 2, and that's the first one.
Helium only has one layer of electrons, right?
Yeah, and it can only
How many can that layer hold?
2.
It can only hold 2. So that is considered a full layer. That is the only element that has 2 valence electrons is considered to be full with 2 valence because it has its first layer full. So your first 3 are argon, neon, and helium. And the other obvious thing that we have pointed out over here is it's in the same column as the others. It's the same column as the others. In fact, if you look at number 2, what do you notice about the location of the elements in number 1? They're all in the same column. Now we're going to call those columns, what are those columns called? Families. They're all in the same family. And what do we know about family members? They're related. So these elements are related in some way. Okay, they have some of the same properties. Like it or not, you have some of the same properties as your family. Okay, so these elements are going to have some of the same properties as the other elements in that column. That's why they're called a family. Which elements had only one valence electron?
Hydrogen, lithium, sodium.
So if you look, you see hydrogen had 1 valence, lithium had 1 valence, sodium had 1 valence. So you're going to write the names and the symbols of all those 3 in the blanks. Hydrogen, sodium, and lithium had all the 1 valence. And what do you notice about the location of those 3 elements? They are also in the same family, which means they are related in some way. We don't know how yet, but we know that they are related in some way. We know that one property they share is they have the same number of valence electrons. You're looking at number 5? So Caleb has made the discovery that, and you're YouTube famous now, Caleb, because I've said you on the video. He's made the discovery that he's looking, and these valence electrons are going in order. Well, let's look at number 5. What do you notice about the number of valence electrons as you move from left to right across the row or periodic table? By 1, okay? They're increasing by 1. As you move left to right, they're increasing by 1. If they're not increasing by 1, then something's wrong on your Lewis structures. But you should be able to look at your Lewis structures, also called dot diagrams, and see that your first column has 1 valence. Your second column has 2 valence. Your third column has 3, 4, 5, and so on up to 8. With the exception of which one?
Neon.
Neon has 8.
Oh, 8.
Helium. Helium's our exception because it has 2, but it's got a full outer level. Okay? So that's the reason helium is not right over there next to hydrogen. It's all the way on the other side because its outer level is full. Even though it only has 2, it's still got a full outer level. So it's going to behave more like those ones on the end. Okay? All right. Number 6. What do you notice about the number of energy levels or shells as you move down a group or column on the periodic table? The shells, the electron levels.
They get more.
They are increasing by 1. Okay? They are also increasing by 1. So what it's talking about, in case you missed that, is talking about the circles. How many circles are in the first row? Now that first row, or period as we call them, it only has 1 circle. That's because it only has 1 electron layer. But if you go to the next row, starting with the lithium, going all the way through the neon, it has 2 circles, 2 electron layers. You go to the next row, it has 3. So what do you think the next row would have?
4.
4. Okay. 7. 7. In fact, let's look at that now. If we look at the periodic table, what you've got on your periodic table that you built is these 5 elements and this chunk of elements right here. So you see that this is 1 level, this is level 2, this has 3 electron levels. So how many is this one going to have?
4.
4, 5, 6, 7. All right. Now these 2, they're in 6 and 7. They're actually inserted right here. But if we insert them right here, how long is that going to make the periodic table? Too long for a piece of paper. Okay. But so since these have some properties that are just for them, they were able to take this chunk out and put it on the bottom. Okay? Jump off.
There's numbers going down the side on like the periodic table you get on the annual assessment. Does that say on the notes electrons?
If it's going down the side, probably not. Probably not. I'll look at that after we finish this. All right, so number 7 says elements are organized into families according to their physical and chemical properties. Identify the elements that you used in step 5 that belong to each family based on the number of valence electrons. Give the name and the symbol for each. So let's look at the alkali metals first. So we're going to learn that every column or every family has a specific name. The first one is the alkali metals. They have 1 valence electron. Well, how many do we have in that first column?
1.
We have 3. How many blanks are on this paper beside alkali metals? 2. Which 2 are we putting in there? Why not hydrogen?
Because it only has.
It's not a metal. Hydrogen's not a metal. It's an exception too. So your lithium and your sodium are your alkali metals. Hydrogen is actually anybody know? It's a gas, okay? Hydrogen is a gas. So it's not going to be an actual metal, but it's over here because it does behave like some of these sometimes. Okay? So, yes, sodium is a metal. Yeah, when you eat salt, you're eating a metal. You know how every family has an outcast? Okay, hydrogen has a lot of properties like these, but it's still an outcast because it's a gas and not a metal. So it's kind of an outcast here in the alkali metals. In the air. Or when it mixes with oxygen, it's in the water. After the video, we'll talk more. Okay. All right. Alkali earth metals. What do we have?
Beryllium and magnesium.
Beryllium and magnesium. keep going down with your boron family, your carbon family, your nitrogen, your oxygen, your halides, and your noble gases. Because they're all in order. So keep going down and fill that out. I'm going to give you time to fill that out real quick. Y'all don't forget the noble gases. The noble gases are that column on the very right side. Okay, the noble gases are the elements that are on the right side. And you'll see 3 blanks because all 3 of them are considered noble gases. For our virtual students, make sure if you have any questions that you message me. Number 8 says, what do you notice about the location of the elements in each family? They're all in the same column. So if we look at the periodic table, I said you've got these 5, and you've got this chunk on the little periodic table you have built, right?
Yes.
Okay. You notice a pattern, right? That every time you move 1 to the right, the valence and electrons are increasing by 1, correct?
Yeah.
Okay. So we've established a pattern. Remember, periodic means in a pattern. Periodic table is full of patterns. Some you've noticed, like the atomic number 1, 2, 3, 4, 5, 6, 7, 8. Those atomic numbers go in order, right? So another pattern we noticed today is that the valence electrons go in order by 1. 1, 2. Now the saying I use in my class is we skip the dip. Okay? These are their own special group. And we're going to talk about that next unit, but we're going to skip the dip here, okay? They're not falling in this pattern. So we've got 1, 2, skip the dip, 3, 4, 5, 6, 7, 8. So if I look at this pattern and I look at the periodic table, I can look at this column and go, oh, if it's this column right here, 1, 2, skip the dip, 3, all of these elements have 3 valence electrons. That's what makes them a family. That's their thing they have in common. It's like you have genetics in common with your family. The number of valence electrons are what they have in common. Because of that number of valence electrons, that makes them have other things in common. That gives them some of the same properties. Okay? Another pattern we saw is that when we go down, we have one layer of electrons, two layer of electrons, 3, 4, 5, 6, 7. Okay? 7 is our highest number. So the noticing about the location of elements in each family, yes, they're all in the same column. Each family is the same column. Think a family tree growing taller. This vertical is your tree. Okay? Number 9, how would you classify hydrogen? What I want you to know about that is hydrogen is a gas, not a metal. Okay, that's what I want your takeaway to be for number 9. Hydrogen is a gas and not a metal. But it's going to stay in this first column because it only has one valence electron. So using the patterns that we have, it wants us to predict how many valence electrons are going to be in the elements that are listed. So the first one that it lists is barium. So we got to find barium. Where is barium?
It's on the second row.
Okay, second row or second?
Second.
Family, okay? So right here, so there's barium right there. So how many valence electrons would barium have?
2.
2. If we follow the pattern, 1, 2, it's got 2. The next element that it gives you is lead. What's my symbol for lead?
PB.
PB. Where do you see PB?
Right beside titanium.
There's
Below
There's PB. And so if I look, it's in the carbon family. So I'm going to count 1, 2, skip the dip, 3, 4. So PB would have how many valence electrons?
4.
4. Where's xenon?
Last row below krypton.
All right.
Last family.
So it's in this last family. It's right below krypton. So we're going to use our pattern. 1, 2, skip the dip. 3, 4, 5, 6, 7, 8. So how many valence electrons would xenon have?
8.
8. Now isn't that a lot easier than drawing out that whole Bohr diagram? But I made you do the Bohr diagram to know how those electrons are placed and how you get those valence electrons. But now you know the shortcut, okay? You're going to get frustrated with me a lot because I'm going to teach you how to do something the long way. Then I'll show you the shortcut. But you got to know the long way to understand what's going on, okay? That's right. Potassium. Potassium, what's its symbol? K, right here. How many valence?
1.
1. It's in the first family, so there's 1 valence. All right? All right, virtual, if you have any questions, you make sure you message me. You got to understand this to get the units coming up. All right. Stop this.